Hello everyone, this is Prakash. Welcome to the day one of our GenAI Tech to Master series. So today in this video, we'll understand the basics concept about the LLMs and how it can be controlled over the parameters. Okay. So first of all, what is a large language model or what is a LLMs? Okay. So basically LLMs, it's an AI model which trained on humongous amount of data or large amount of data like your text, websites, Wikipedia, and codes or articles. Okay, and understand and generate human like language. Okay, let's say for an example, you have a problem like what is the capital of India is. Okay, so how LLM will understand that and how LLM will predict that. So first of all, with the embedding architecture or transformer architecture, which is the heart of LLM, will understand the context of this prompt and predict the next possibility words. So next, let's understand how LLM generate text and give you the output. So like LLM generates tokens, then assign probability score to each tokens. Okay, and give you as the output of the highest probability tokens or highest probability words. Okay, so for an example, the cat sat on the. You have a blank statement here. Okay, so these are the answers generated by LLMs with probability scores like math has 35%, floor has 25% probability, there has 15%, and so on. Okay, so here math, since math has the highest probability, the next output by the LLM more likely to have math over floor, chair, and row. Okay, so let's say for every time you do not want math here, you expect floor, chair, roof also in your LLM's output. So how LLM can be controlled? Yes. So LLMs can be controlled over the parameters like temperature, top P, top K, which we'll understand in the next coming slides. So temperature, basically temperature controls the randomness or creativitiness of the model or LLM. Okay. So when you have low temperature, like it's near to 0 or in between 0 to 0.5, the model is too much focused and predictable. So you are most likely to receive one answer in most of the time. Like the probability of like it picks the highest probability of words in most of the time. Okay, and when the temperature is bit high, it is likely to have a creative response or diversity response. Okay, temperature range can be 0 to infinite, but in real world use cases, it considered to have 0 to 2 in the range. Okay, 0 is kind of very less or low temperature, and 2 is the highest temperature. When you have 2 as a temperature, your model is too much creative and diversity with the answers. Okay, let's say for an example, you give a prompt, write a greetings. Okay, so when your temperature is too low, the model is likely to respond with hello, how can I help you today? But when your temperature is bit high, you can see the answer is bit creative. Okay, so we can test that thing also in ChatGPT. Let's say I'll give a prompt to ChatGPT that I want to test the LLM parameters, how it is works, and you are a testing environment to test the next word with the parameters, and I'll give you the parameters and you give me the answer based on that. So let's say my prompt is write a greetings. Okay, and my temperature I want to pass it 0.3. Okay, let's see the answer. So hello, hope you are doing well today. How can I assist? Okay. So this is very generic thing. Let's say I increase the temperature to 1.5 now with the same prompt like write a greetings temperature 1.5. Now you can see this is what is the result, right? Hi there, parts of amazing human. Hope you are hope your day is sparkling with good vibes and expected wins. How can I jump in and help you today? Like you can see, the kind of response you are getting with the temperature of 1.5. Okay, when it is near to 2, then your model is kind of too much creativity and diversity in terms of the response. Okay, now let's understand another parameter which is top K sampling. Okay, so let's say you have a sentence, the weather today is, and next is your blank statement where you want the model to fill out the next word. Okay, your model will have all the possible words. with the probability scores. Like Sunny has 30% probability to be the next word. Beautiful has 22. Nice has 80, 18. So likewise, you have warm, cold with the corresponding probabilities. So let's say when your k value is 3, like you can say that k is the real number and top k means top. When your k is 3, you want top 3 predictive words. So for in each iteration, when your top k is 3, you are most likely to receive only one word out of these 3. Okay, when your top k is equal to 5, you are most likely to receive one word out of the 5 words. Okay, so how to or when you use top k, when your data when you are dealing with structured task, or you want predictable response, you use top k as your parameter. Okay, then top key or nucleus sampling, it is also called as nucleus sampling, to the top key parameter. So it's basically accumulate the probabilities of the topmost probabilities. Like, so let's say top p is 0.80, or maybe 80% is your threshold. Okay, so when your threshold is 80, the model will accumulate the probabilities. Like it will add the probability. Like for sun is 30%, then plus 22%, which is 52, then 18% is your 70, then 12% is 82. So you have the cutoff is 80, like your threshold is 80. So when are running the model, and the model will predict the word between any 4 out of these words. Okay, when our probability threshold is let's say 50, then you are most likely to receive only 2 words in each iteration. Okay, let's have a example, like the today's weather is and the parameter. Okay, here pass the prompt. Okay, then our equal parameter top k equal to 3, let's say. Okay. Today's weather is sunny. Okay, now let me run this test statement another time. Let's see the answer. Today's weather is cloudy. Okay, let me run another time. Today's weather is sunny. So it is most probably give you the result between top 3 words. Okay, today's weather is cloudy. So you are most likely to receive sunny, cloudy, rainy. In each of the iterations. The same works for the topic. I don't want to extend the video, so yeah, you can test it by your own. And when to use topic, when you want the model to give more creativity response and diversity response. Okay, and the best approach is to have a combined top P and top K to have a balanced response of the LLM models. Okay, and next is the context window. So basically, context window is the total number of tokens the model can process, including inputs and output in single iterations. Okay, like it's kind of how or how much the model can memorize. Okay, let's say you have I passed this prompt in my first iteration. Okay, and I receive this is the answer from LLM. So in my next iterations, the model will consider these two tokens, the number of tokens used in these two response, and the tokens used in this one. Like for my next iterations, it will combine the tokens. Okay, then give give us the next prediction. So similarly for the next iterations, for this one, it will combine all the tokens used in the previous iterations. Okay, and give you the next predicted work. So that is how the context window is works. Like it's take all the input and output tokens for the next iterations. Okay. So for example, GPT-3 has 4K. So or I don't know. I mean, I'm not sure about the exact numbers whether it is correct or not. But for an example, GPT-3 has 4K and GPT-4 has 120K. Context windows. Like the model GPT-4 can memorize up to 120K tokens. Okay, Claude has 200K and Gemini 1.5 has 1 million plus context window. Like it can memorize up to 1 million tokens when you are interacting with the GenAI applications. Okay, why context window it matters? Basically, when you are building a chatbot, you do not want the chatbot to process kind of more than a million tokens, because your chat window is basically for simple QA and like question and answer and quick translations, or maybe quick answers. So you do not want the chatbot to process kind of 50K or 40K of Word documents. So you can limit the context window for the chatbot. Okay, because for each tokens you are paying to the LLM, like for each tokens or API calls, you have a cost involved. So you do not want to waste your tokens unnecessarily. So you can use the context window to limit the token size, okay, for the API calls. Similarly, how when you want to process document analysis, you can range it up to 30 to 120K on course review. You can have it is 128K. When your book length content is 200K plus, then you are processing the entire book, then you want a higher number of context size. Okay, so that's all for today, guys. You have a quick reference here, like temperature control, the randomness, and the creativeness of the model. Top K is limit the output response, like K most probable words. And top P, it's kind of dynamic selection until the cumulative probability with a threshold. And context window is the maximum number of tokens the model can memorize or put as a input token. So that's all for today, guys. Thank you.